Today, we're going to be going over generating known unknowns through known knowns. And in conjunction with this, we'll also be releasing an open source framework that you can use immediately. So I'm Marcus LaFerrera. As Joshua said, I'm a security strategist here at Splunk on the Surge team. Pretty much my entire career has been supporting the DoD in one way or another, most recently over at DARPA, where I was on a few R&D programs. Some of you may have heard of me before from Stoke, which is one of my more popular open source frameworks that I formerly led. And it was, or is just a malware analysis pipeline that you can use at scale. And pretty much everything that I do is really meant to automate my job away. So before we go into the real meat of today's presentation, I want to go into some background first. Some of you may have heard about this. A little over a year ago, there was the SolarWinds compromise and the Sunburst malware. As part of our rapid response process here at Splunk, when we're dealing with major incidents such as this, we try to provide some value back to the community as well as our customers. And so what we ended up doing was building a whole bunch of infrastructure to replicate some of this attack. And what we quickly found was it was really hard to do. It required a lot of resources, it required a lot of software and time to build out. And so there were a lot of roadblocks throughout the entire process. Thankfully, we were able to overcome them, but things ultimately could always be done more efficiently. As a result of SolarWinds, we started to rethink how we can develop some capabilities to actually detect supply chain attacks. And the result of that is a white paper that we published a few months ago that focused on using JA3S hashes to detect supply chain attacks within critical infrastructure or servers. And as we were going through that, again, we discovered that replicating some of the attacks was really difficult and time consuming. And we knew that there were different ways that we could do it, but we wanted to minimize the overhead. And we wanted to also be able to allow customers and the wider security community to be able to replicate a lot of what we were doing. Now, I know a lot of the people attending this are researchers or network defenders. And so you know that there's a lot of data out there. There's all sorts of PCAP and syslog data coming inbound and all sorts of cloud data and logs that are coming inbound. But a lot of times we just don't have the right data to prove out our theories or to test our detections. And so at that point, we really knew that there had to be a better way to accomplish this. And that's where Salo comes in. Salo is one quick caveat. It is a work in progress. This isn't something that is production grade at this point, but we still wanted to share it with the community because we believe that there is a benefit to it. So Salo stands for Synthetic Adversarial Log Objects. And it's really just a framework that allows us to generate log events without actually having to build all of that infrastructure, deploy the services or servers, or even have the exploit to replicate the attack. So it allows us to create these log events in a repeatable fashion without the need for additional infrastructure. I know what you're thinking, why another fake log generator? Because there are several out there and they do great at what they are designed to do. But for Salo, we needed something that had a low barrier to entry and minimal effort to replicate logs. There's a lot of complicated tools out there that require some additional software to be installed and a lot of dependencies, and we really wanted to minimize that. And we didn't want a whole lot of effort into building out the ability just to replicate a few logs. We also needed the process to be repeatable and highly customizable. So when you're replicating some of these events, there might be just sometimes where you just want to tweak one minor thing. We didn't want there to be a lot of overhead in that customization or that process to be able to repeat the generation of logs. So before we get really deep into everything, let's go ahead and walk through a really, really simple scenario so you can wrap your head around what we're talking about today. So we're going to start with generating just a new file called dns.yaml. And this is our recipe. We'll go into what that is a little bit more later. And in it, we're just going to have a session with an event where we're just generating a Zeek DNS log. And this is literally all that's needed right now. So if we go ahead and run that, you can see that we've now generated output with completely randomized data, but that's relevant and timely for that specific log event that we want to generate. And that's all there is to it, to generate a single Zeek DNS log event without actually having to build anything else. Let's say that we want to customize this a little bit now to make it more relevant for what we're doing. Now all we have to do is add an option for a DNS query. And in this case, we're going to generate a log that is for defsecurity.com. And then we're going to generate another log event, which is the Zeek con log. So if we go ahead and run that, you'll now see that we've generated 2 log events. And if you look closely at all the values here, you can see that they actually correlate with one another. Not only is the timestamp extremely similar, but the UID as well as the source IP and destination IP and everything else is in line. So if you wanted to run analytics on this, this is what a real world DNS query would look like in your logs. And we can also simply configure the output to send the data to Splunk as well as a raw log file. All right, let's go ahead and dig into the specifics now. So you can think of each one of these terms as a different layer to produce the output for Salo. Let's go ahead and start with a recipe. A recipe is just where we define our scenario. This is kind of the core scaffolding to say how we want to produce the logs and what we want those values to be. This is an actual example of one of the recipes that are out there. And this one is just going to generate a few logs that resolve a domain and then beacon out over TLS. So let's go over some of what we're seeing here. First is the options. These are actually the global options. So these will be the defaults. If an event down the line in one of the sessions does not have a source IP defined, this will be the default source IP. And we can do this with any of the options that the individual events support. We also have options for time. And what is extremely powerful here is you can not only define the starting timestamp here, but we can also introduce jitter. And jitter is just useful to ensure that we're introducing a little bit of randomization to the timestamp, so everything isn't down to the millisecond identical. We also have an option here for cadence, which is a cron-like syntax that allows us to define the delta between timestamps of events. And this is really useful if you want to say, have a beaconing activity that is going outbound every 10 minutes or every 2 weeks or every 2 years. It's really up to you, but the cadence can be defined down to the second. Now we have sessions and events, and sessions are just a grouping of events. And the events really can be glued together, and we'll go over that in a little bit more detail here. So this event is just going to be the Zeek conlog that we're generating. The repeat value here allows us to repeat this event and any child events that are spawned from this. In some cases, you might want to have this event generated 100 times or 1,000 times. This is where you would define that. We also have options that we can set. So up above, we have the global options. This one is event specific, but any spawned events from here will inherit all of these settings as well. So in this case, we're just setting the destination port to 53, the protocol and the service. Now we're going to go ahead and spawn a Zeek DNS log event. And so this Zeek DNS log event will be inheriting all of the randomized data that hasn't been defined from the Zeek con log. So the source IP and destination IP, the UID and everything else will be inherited. So we don't have to worry about redefining that or doing anything special with that. We also have likelihood defined here. And what the 100 there means is that this event will 100% be generated. And we can go ahead and introduce a different value here. So if we want it to be 50% of the time, this event will be generated. And then we also have save values. And this is really great if you want to reuse some of the values across events and across sessions. So in this case, we are saving the DNSR data or the response data in the Zeek DNS log into the variable first DNS response. And if you look at the right-hand side of the screen, that first arrow, you can see that we're defining the destination IP as the value of the first DNS response. And the .0 there just means that we're using the index value of 0 because the DNS response can have one or more actual IP addresses in it. And then you can see that we're using a couple of others to include the timestamp and first DNS query. Salo recipes also support recursive spawning to an infinite degree, so long as your CPU can handle it. Here we are going to spawn the Suricata DNS model. And the reason why we're spawning it from the Zeek DNS model is because we want to inherit all of those settings. So essentially what we're doing here is creating two log events of the same event. So all of the resolutions, the source IP, destination IP, ports, everything will be inherited into the Suricata DNS event. So it'll essentially be mimicking exactly what the Zeek DNS model will be generating. And we can have multiple events in a session. And so here what we're doing is now we've generated our initial Zeek DNS log query and Suricata DNS log query. Now we're going to generate the logs that will mimic the actual beaconing outbound over TLS to the C2. And if you look here, you can see that we've introduced an additional jitter as well. And so the timestamp will take the previous timestamp from the Suricata DNS model, and it will introduce a jitter of a minimum of 600 seconds and a maximum of 1200 seconds. So the timestamp for this actual outbound beaconing will start at sometime between 6 to 1200 seconds after the fact, introducing what some adversaries will do, where they won't necessarily beacon outbound immediately after the DNS query. So let's move on to Stencils. Stencils is an optional layer, and it allows us to add some more complex data scaffolding for our output. And so in this case, we can actually programmatically define what the values are for our log output. On the left, we have a stencil, and on the right, we have the recipe. This stencil will mimic the Sunburst DNS query activity, where it would generate a encoded host name and then a few other things and avsmcloud.com. And so based on the response, it would indicate what the adversary wanted to do with that compromised host, because the host name would be encoded into that DNS query. So here we're mimicking some of that activity. And on the right, you can see that we're just using the stencils of Sunburst and Sunburst DNS query to generate the data. And then we're going to spawn the log events that we want to generate. So in this case, we're going to generate a Zeek connection model for the initial DNS outbound, as well as a Zeek DNS query log and a Suricata DNS query log. And it will just use the values that are generated from the stencil to fill in the gaps for the log event. So we can really create a lot more complex log events that mimic actual adversarial activity, so long as we can represent it in code. Now, if we go ahead and run this, this is an example of the output that we would receive. And you can see that the destination IP is a known Sunburst IP address that was used at the time. You can see that we now have an encoded string in the DNS query, as well as a valid answer that was used by Sunburst, indicating what the action should be. And down below, there's a portion of the Suricata DNS log that was created as well. The next layer is events. And the event layer is really just the generation of the individual log object itself. As you've probably seen throughout a lot of this code, it's using Pydantic. If you're not familiar with Pydantic, don't worry about it right now. Just know is that we use it to define the actual structure of the log events. And there's a lot of benefits to using Pydantic. A couple of them being some of the native model features is really data validation and type enforcement. For example, in a log event that's generated, you always want to make sure that the source IP is actually an IP address. By using Pydantic and the models that it provides, we can really enforce that with minimal code and minimal overhead on the developer's part. It also supports field aliasing. So in many cases, we want to ensure that we're passing data in between the models appropriately. So for instance, a source IP address, Suricata treats it as source_IP, whereas Zeek treats it as id.orig_h. But we need a common naming structure on the back end to ensure as we're passing this data between the different models and the different events, they all stay in sync. And so field aliasing allows us to do that because within the Zeek model and within the Suricata model, we can have a source IP value, but the output would be different. And that's where field aliasing comes in handy. And it also supports randomized field content. So in a lot of cases, we don't want to necessarily have to define the value for every single field that's in a log event. Randomized field content allows us to just generate the log event with random data without really having to worry about that. This is an example of an event for the Zeek con model log. And as you can see, we have a bunch of different fields here. There really isn't a whole lot more to the code outside of this, but it will generate the output that you see on the right. And you can see that most of this data is completely randomized. We didn't have to, if we were creating a recipe, we wouldn't have to worry about defining what each one of these fields is. Salo and the models will handle that for us. We can only worry about defining the fields that we specifically want. These are some of the event models that are currently available today. We support most of the Zeek logs, a couple of the Suricata, even Sysmon and GitHub audit logs. And the final layer is output, because all this data generation is completely useless unless we can do something with it. Right now, it can output to console, raw log file, as well as directly into Splunk index. There's a really simple configuration file that allows you to kind of customize that. And there are modules that allow you to expand on this too. So if you wanted to develop this for other outputs or other endpoints, it's a pretty simple process to do. And that schema is really, really flexible. Because we're using Pydantic, JSON output is supported by default. So you really don't have to do much to support JSON. The second one that you see here down below is to leverage Jinja templates to actually produce the output, which makes it extremely flexible because all you have to do is generate a template and the data will be sent to the template and produce the output. So for example, if you want a complex XML schema or a syslog output, it would be really simple to replicate. There really isn't a whole lot of overhead in producing that output either. As for a roadmap and my wish list for this, I would love more community involvement to develop more recipes and stencils so we can mimic a whole wide degree of adversarial activity. I'd also love more community involvement to develop some of the event models so we can support some additional log output as well to make it even more useful. And with that, here's some links for the code as well as the documentation. I probably spent more time on the documentation than I did on writing the actual code for good reason, because if there isn't good documentation, it becomes extremely difficult to actually use something. But it's freely available, it's ready to go. I would love some feedback. And if you have any questions or any issues, feel free to contact me here. And with that, I guess we can open it up for questions.
Great, thank you, Marcus, for the excellent talk on this and very, very important work. You just answered this question, but I'm going to pose it again to you anyway, because it's a good comment. This is from JP saying, this is very cool. What's the roadmap for this? Any thoughts making it a Splunk app?
So one of the goals behind this was actually to make it Splunk independent because we needed something, or rather I wanted something that was useful not just to Splunk customers, but to really everyone that's trying to work on building out detections as well as the research and development community. But yeah, the roadmap is really, I would just love to be able to expand on mimicking adversarial activity, as well as trying to make the event models as wide as possible so we can do more than just what's there right now. So for instance, if we can generate event models for cloud-based logs or expand more into Sysmon for Linux and Windows, that would be terrific as well.
The next question we have from Josh asking, is there anywhere with a good list of log generators?
No, I could not find one. By doing some research, I was able to find some. But yeah, I couldn't find like a good comprehensive list of what was out there. And several of the ones that I did find were no longer or appeared to be abandoned in some way or another.
Okay, next we have, what are some additional event models you'd like to see added to this?
Oh man. I would love to expand some of the Suricata logs that are in there. If this could be expanded to Azure, GCP, and AWS logging as well, that would be terrific because I think there's a lot of data that's really missing to be able to mimic adversarial activity in those environments.
Okay. How about another one from JP in Discord asking, have you considered this for purple teaming exercises?
Oh, absolutely. Most of what we've seen in terms of use cases, I think have really been geared towards research and development. Because if you look at a lot of the R&D data that's out there that researchers are using, a lot of those data sets are at least a year or two old, some going back even decades if you want to look at some of the DARPA data from back in the late 90s. But I think there's an absolute application here for purple teaming because if you don't necessarily have to have the entire kit for the red side, you can just really produce the log output that you want to validate a lot of the findings.
Great. Jim asks, can you expand on the difference between models and stencils?
Absolutely. So I'm using a lot of these interchangeably, but stencils are essentially a model that doesn't produce the output. It's kind of the scaffolding for the output. So a stencil, you can programmatically define how you want that output to be. So more complex things like mimicking a Cobalt Strike DNS query or C2, or like I had there, the Sunburst DNS queries. That's where stencils really come into play. They don't produce log output. They just produce the values that the event models can leverage for that log output. And the event models are really, they're meant to mimic the actual log event itself. So the Zeek log or the Sysmon log.
Great. Now, so if you don't mind me asking a personal question here, because FlowCon's known for getting a pretty good student audience. How did you know you wanted to get in this field, and kind of what has been your path to getting and working at Splunk?
Oh man. So my path to working with Splunk has been a long one. I have over 20 years experience right now. And I pretty much started an ISP in the late 90s managing some BSD systems, joined the military, and then my entire career has pretty much been DoD in the contractor world. But yeah, it's for the student world, critically think about everything that you do, have that thirst for knowledge, and make sure you show that to anyone that you want to ultimately work for. Because I don't necessarily, especially when I look to hire somebody, I don't necessarily look to hire based on experience. I look to hire based on where their thirst for knowledge is and where they want to go with their career.
That is terrific advice. Thank you very much for that, Marcus. Next one, we got one from Sam in Discord. Do you have a process to take down samples of known bad traffic? For example, PCAPs, and build recipes that mimic them, anonymizing them along the way? Or is there a smarter way to build models from real world traffic?
Yeah, so that's a great question. It kind of opens up a lot of doors. Let me tackle the first part of it first. My process has really just been taking a look at what adversaries have been doing and then developing recipes based on that. The models themselves, I consider completely independent of the recipes. The models I basically just build for just the log event, not really understanding what the adversary is doing, but I just want to mimic what that log looks like. To actually mimic them, that's kind of where I look at blog posts and determine what, say, perhaps URI is, or a specific method for a DNS query or something like that. But is there a smarter way to be able to do that? Absolutely. Something that has been brought up and we've been discussing, and I would love community involvement in this too, is to be able to build dynamic models that can take an already existing log event and produce a model based on that log event. It's something that myself and a few others have talked about, but it's still unknown exactly how to implement that the best way.
Okay, and what brought you to FlowCon, Marcus? Have you presented or attended in the past, or were you invited to speak this year? What's your FlowCon history?
So with FlowCon, I have had a lot of involvement with SCI in the past, and I've always known about FlowCon. There's been several people that have been on the board there before that I've been close with over the years, especially while supporting DARPA. So that's my primary focus for it. But I also, the timeline for when we wanted to release Salo and when FlowCon was happening was perfect. And I thought, what better audience to share something like this with than some researchers and network defenders that can actually leverage it in a good way.
Terrific. This is the last one we have in the queue. Have you used this for any real world research?
Yeah, so there was kind of a primitive version of this that we actually used for the JA3 S white paper that we wrote back in October, where we were using this to mimic some of the SolarWinds activity beaconing outbound over TLS.
Great. So that's it, Marcus. Any final thoughts from you? Anything you want to add before we move on to our next talk?
No, I think the biggest thing is I hope that people can find use out of this and it can really make a difference in their day-to-day lives, especially for network defenders and researchers.
Yeah, absolutely. Thank you for this important work. Hopefully the attendees will see you over on Discord and get to interact with you there.
Absolutely. Thank you.